All right, let's look at lesson 85. And today's lesson, we are going to be looking at multiplying. Specifically, we're looking at multiplying by tens, 100, by 10, 100, and by 1,000. This is going to be a fun lesson. It's quick, it should be easy because multiplying by powers of 10 is fairly simple and straightforward. Okay, so let's get right into it here. 10, 100, and 1,000. These are all multiples of 10, meaning uh, 10 times something gives you each of those numbers. And they're also powers of 10, meaning 10 is 10 times itself just one time, 10 to the first. 100 is 10 times 10, or 10 squared. And 1,000 is 10 times 10 times 10, or 10 cubed. So they're all powers of 10. 10 to the first, 10 to the second, 10 to the third. Okay, if you haven't already, please do these warm-up questions here. Again, it's asking you to look at the patterns in order to help you with some subtraction. You're working on multiplication and addition and subtraction there. Always make sure you're fine-tuning and honing your skills here with these different operations. This pattern down here, find the next two numbers in each sequence. So you're looking again for patterns. If you remember, I said a lot of math is all about patterns, and the more you see the patterns, the easier the mathematics would become. So you're looking here at any pattern you can find in how you go from one number to the next. So it's going from 1 to 4, 4 to 9, 9 to 16, and then you try to figure out what the next number would be. Okay? So as you look through these, you're looking for, am I adding certain numbers? Am I multiplying by certain numbers? What's the difference between one number and the next number? There's lots of different types of patterns that you look for, and those patterns are mostly going to be dependent on adding or subtracting or multiplying or dividing by some number. Okay? So here it looks like maybe from 1 to 4, to get from 1 to 4 you would add 3. To get from 4 to 9 you would add 5. To get from 9 to 16 you would add 7. So it looks like every consecutive number you're adding an odd number starting with 3 and then going every odd number after that. So 3, 5, 7. Looks like maybe the next number we would add 9 to 16 in order to get 25, and then you would add 11 to 25 to get 36. Okay? And down here, you're going from 1 to 3, 3 to 6, 6 to 10, 10 to 15, 15 to 21. It looks like here we might be adding, well, let's just try some numbers here. You're adding 2, and then you're adding 3, and then you're adding 4, and then you're adding 5, and then you're adding 6. So it looks like we're just adding a bigger and bigger number that's increasing by 1 as you go through this particular sequence. So we would get the next number by adding 7, so that would give us 28, and then the next number we would add 8, so we would get 36. Okay? So keep looking for those patterns. Today's new concept, as mentioned before, we're multiplying by 10, by 100, or by 1,000. So anytime you multiply just by 10, basically you can take that 1 right there, and 1 times anything doesn't change the number. So 1 times 123 is 123. But then we remember we really were multiplying by 10, which means we have to add a 0 at the end, because it's not just 123, it's actually 1,230 would be the correct answer. So anytime you multiply by a power of 10, you just add that number of zeros at the end, and you don't have to worry about doing all the multiplication process. Okay? If you multiply by 100, then you can just take, again, 1 times that number, and you get 1, 2, 3, but you would add 2 zeros at the end. So this would be 12,300. And if you multiply by 1,000, you would just, again, multiply by 1. So in this case, the same value, 1, 2, 3. But you would add 3 zeros at the end and get 123,000. So it should be straightforward. quick and easy. It's a great skill to have because you often are multiplying by powers of 10 in mathematics. Okay? All right. Let's look at some example problems here. It says right here, when we multiply dollars and cents, we remember to insert the decimal point 2 places from the right-hand side of the product. So, again, you're just multiplying by 100, but remember with a decimal point, so if you take 1 times 1.23, you get 1.23, but you're multiplying by 100, so you don't just add 2 zeros at the end, you are actually moving the decimal point over 2 places when you multiply by 100. So that would be $123. That is what we're doing up here as well. When you multiply by 100, all right, when you took 100 times 123, you get 123. Here's the decimal point if you just take 1 times 123, but we're really multiplying by 100. So that 100 moves the decimal point over 2 places, and we fill with zeros. So that's how we get the 12,300. Okay? So in summary, when you multiply by 10, that moves the decimal point over 1. When you multiply by 100, it moves the decimal point over 2 places. When you multiply by 1,000, it moves the decimal point over 3 places. Okay? So if I take 37 times 10, I know immediately that is going to be 370. $6.12 times 100, I know immediately if I move the decimal point over 2 places, that's going to be $612. 45 cents is 0.45 dollars, 45 hundredths of a dollar, times 1,000, 1, 2, 3, fill with a 0, and I get 450. Okay? All right. And you can look at the solutions down here. Let's do these really quickly here. 365 times 10. When you write 365, you don't place the decimal point, but it's there at the end. You don't need to put it there. But when we multiply by 10, we would move that decimal point over 1 space, and we'd have to fill with a 0. So we get 3,650. 52 times 100 is 5,200, or 5,200. 7 times 1,000 is 7,000. $3.60 times 10, you would move the decimal point over 1 place, and you would get $36. And you can put, since it's currency or money, you can put 2 zeros at the end to signify the values for tenths and hundredths of a dollar. 420 times 100, again, 420. The decimal point's at the end, so we move it over 2 places and put placeholders there, which are zeros, so 42,000. And $2.50 times 1,000, move this over 3 places, and you get 2,500, so it's 2,500 or 2,500, and that's currency or dollars, so you can put 2 zeros after the decimal point if you want. All right, a couple comments about the mixed practice here. So this problem set, we're looking at this graph for the first 3 problems. This is good practice to get used to analyzing a graph, looking at data, looking at how it's organized, making sense of it. Great skill to have, so take your time with these and make sure that you really look at all the information. And there's lots of information here. You have to look at the title, you have to look at each name, figure out what is being graphed here. Make sure you look at your numbers and the scale of those numbers. Are they counting by 1s, 2s, 3s, 4s? Are they counting by 10s? Okay? And then read all of the data very carefully. Number 1, which student has read exactly twice as many books as J? So let's find J first. J has read 4 So we want to go twice that up to 8. And that person, if we go 8, we find that, oh, yep, Maria has read a total of 8 books. Number 2, Hiroshi's goal is to read 10 books. He wants to get way out here to 10. How many more books does he need to read to reach that goal? Well, here's Hiroshi. He is at 6. So he's got to get to 1, 2, 3, 4 more books in order to reach all the way to 10. So 4 more. If the books Annie has read have an average of 160 pages each, how many pages total, I'm assuming they're saying total, has she read? So Annie here has read, wow, a whopping 9 books. So she's read 9 books. And on average, each of those books has 160 pages. It doesn't mean that every one of the 9 books has 160. It means that some have more, some have less. But if you were to average all the number of pages, it would be 160. So 1 book on average has 160. 2 books would be 2 times that. 3 times that. But she did 9, so that'd be like taking 160 plus itself 9 times, or 9 times 160. And I'll let you figure that out. Jim saw some pentagons. Pentagons, 5 sides. The pentagons had a total of 100 sides. A total. Each has 5. So all of them together is 5. Or sorry, all together is 100. How many pentagons does he see? Well, if you've got 1 pentagon, has 5 sides, and then a total of 100, so 2 pentagons, you'd have 5 plus 5. 3 is 5 plus 5 plus 5, or 5 3 times. So you basically are having, and that'd be 15, by the way. So if you had 1 pentagon, that gives you 5 sides. 2 gives you 10. 3 gives you 15. 4, total of 20. Hopefully you see what's going on here and you're seeing the pattern. Is basically, if you know the number of sides, then you know how many pentagons there are. And you would find that by dividing by 5. So we're going to take 100, divide by 5, and you should get your answer here. You have 20 pentagons. Sophia bought a rectangular piece of land that was 3 miles long and 2 miles wide. So let's just draw, this would be a great place to draw a diagram here, okay? Great place to draw a diagram. A rectangular piece 3 miles long and 2 miles wide. 50% of the land could be farmed. How many square miles could be farmed? So basically there's a couple ways to do this. 50%, you could just divide this right in half if you want to, okay? And then calculate just the area of half of it. Or you can find the area of the entire thing, and to find area we'll take length times width for a rectangle. So that would be our 2 times 3. So 2 times 3, that's going to give me 6, and this is square miles. But you only want 50% of that, or half of it. So we need to take half of this. So you take your 6 miles times a half, and you would get 3, and that's still square miles. Or you could take 6 times 50%. 50%, remember, is 50 over 100, which is a half, or 0.50. Either way, you're going to get 3 square miles. Max bought 10 pencils for 24 cents each. Read each word carefully. The tax was 14 cents. What was the total cost of the pencils? So 10 pencils, 24 each. So 10 times 24 cents. Here we are multiplying by 10, so you just move the decimal point over 1 place. That's going to give you $2.40. And the tax is 14 cents. So we're going to take our $2.40 and we're going to add on 14 cents. And we're going to get $2.54. $2.54 is your final answer. A full pitcher of orange juice contains about how much juice? Oh, okay, so you're just estimating here. I see. A full pitcher of orange juice. So you're estimating which of these units here would best describe a container of orange juice. Well, 2 ounces is just a small quantity. Okay, 2 gallons. If you think of like a gallon jug of milk that they have in the United States. So gallon and then 2, that's a lot. That's a big amount of orange juice. So it looks like 2 liters would be your best guess. A liter would be one of those thinner containers, plastic containers, and so maybe 2 of those would fill your big glass pitcher. Number 8, draw a triangle so that 2 sides are perpendicular. What type of triangle did you draw? So if you have 2 sides that are perpendicular, that forms always a right triangle. So that must be a right. Sorry, 2 sides that are perpendicular always form a right angle. I put a box there, so this would be a right triangle. 1/4 of the 48 gems were rubies. 1/4 of 48. How many of the gems were rubies? Draw a picture to help you solve the problem. So if you've got all the rubies in a box and 1/4, you've got to divide that into 4 equal parts. 48 is the total, and you want to divide that into 4 equal parts. So if you think of this, maybe it's easier to think of it first, take half of that. Half of 48 would be 24, and then half of 24 is 12. So 4 12s is going to give you 48. Or you can take 1/4 times 48. You could take, if you know that 1/4 is 25%, 0.25 times 48. 48 divided by 4. There's lots of different ways to think of it. In any case, you're always going to get 12. What percent of the gems in problem 9 were not rubies? So we kind of already answered that, because 1/4 is 25%. So if 25% are, then the remaining percent, in order to get to a total of 100, would not be. So that's your 75%. 1,000 fans attended the game, but only 81 fans were pleased with the outcome. So 1,000 were at the game, only 81 were pleased. What fraction of the fans who attended the game were pleased with the outcome? Well, you know that 81 were pleased and a total of 1,000 fans were there, so 81 over 1,000 would be your total number that is pleased. Okay? By the way, the fraction of those is not pleased would be the remaining number of fans over 1,000. So you would have to take 1,000 minus 81, find that number, and then put that over 1,000. So these are the ones that are pleased, 81 over 1,000, and then when you get that number, that's how many are not pleased. Write the answer to problem 11 as a decimal number, then use words to name the number. So you have to take 81 divided by 1,000, and then that's going to be 81 thousandths, okay? So if you multiply by 100 and move the decimal point to the right 3 places, then when you divide by 1,000, you move the decimal point to the left 3 places. So we have 81, and the decimal point is at the end. We don't have to write it, but it's at the end. And we're going to divide by 1,000, so 1, 2, 3. We put the decimal point there, and we fill that space with a 0. So it is 0.081, or you just know that 3 decimal places to the right of the decimal point, that is your thousandths. So you would put your 81 at the end there to begin to fill in the thousandths place. So 81 thousandths, 0.081. Okay, you can do all of these that are asking about computations and operations. Don't neglect them. Walk through them. Check your answer. Make corrections. Make sure you're doing that. Very important to stay very sharp with your mathematical operations. Okay? Let's come down to 27. Find the perimeter and area of this rectangle. Perimeter, you walk around the object. With a rectangle, opposite sides are equal in length. So we've got 10 plus 6 plus 10 plus 6. That would give you your perimeter. Also, I'm just going to write this another way. You got 2 10s, so you could write it as 2 times 10, plus you've got 2 6s, 2 times 6 if you want to. You might see it that way as well, okay? Because the perimeter of a rectangle is 2 times the length plus 2 times the width. Okay? Area is, for a rectangle, length times width. So length times width is 10 times 6, 10 feet times 6 feet. That's going to give you 60 square feet. You could, if one square is 1 foot by 1 foot, you could fit 60 of them in there. Okay? 28, which of the letters has 2 lines of symmetry? Oh, 2 lines of symmetry. Well, the A here has 1 line of symmetry right down the middle. That would split it into 2 equal halves. P doesn't look like P has any lines of symmetry. No, nothing there. Y has a vertical line of symmetry. P does not. Y and A have a vertical line of symmetry. H has a vertical line of symmetry and a horizontal line of symmetry. The vertical line splits it into 2 equal halves, and a horizontal line will split it into 2 equal halves as well. 29. Which angle in this figure looks like it measures about 135? So, remember, if the lines are perpendicular, that's 90. So, half of that would be 45, and a line from one end of the line to the other end of the line, that's 180. And then if you come from one side of the angle and you go past 90 and another half of 90, that's going to be 135. So you're looking for an angle that goes past 90 and then another half of 90 added on to that. And this looks, here's your 90, here's another 90, that looks like that's about 45. And here you'll notice if you start at one end, you're going to go past 90, which would be right there, and you keep going. So this looks like you're about 135 right there. Okay, and Blanca wants to cover a floor with tiles. Which of these shapes of tile will not completely cover the floor? Okay, it will not tessellate, doesn't repeat. So if you remember, you had certain shapes that do. So a triangle does, a square will. There are some that are not going to, because they don't, when they fit together, there's going to be a space. I believe the one that did not was your pentagon. So if you think about this, if you draw another pentagon here, and then try to fit one in here, you're not going to fill in that space with another pentagon. There's going to be a little bit of space there. Okay, so I think a pentagon was one that would not tessellate, so I think it is C. You can double check, go back and look at that lesson, but I think it was the pentagon that would not, if I'm not mistaken. Okay. So if you got questions, let me know, and we can talk about any of these questions or any of these problems and help you through this lesson. Keep working hard. Keep up the good work.